In the years after World War II, the world entered a new kind of conflict, one that was not fought mainly with guns and armies, but with technology, ideology, and prestige. The United States and the Soviet Union emerged as two superpowers, each determined to prove its superiority. One of the most dramatic stages for this rivalry became space. Rockets that were once designed for warfare now carried the promise of exploration beyond Earth. For the United States, the idea of reaching the moon was not just a scientific dream, but a statement to the world about innovation, courage, and national resolve. The early days of American space exploration were filled with uncertainty. In 1957, the Soviet Union shocked the world by launching Sputnik, the first artificial satellite, into orbit. This small beeping object circling Earth created panic and urgency in the United States. Many Americans feared that falling behind in space meant falling behind in military power. In response, the U.S. government accelerated its space efforts and in 1958 created the National Aeronautics and Space Administration, better known as NASA. Its mission was clear: explore space peacefully, advance science, and restore American confidence. The first American astronauts were selected from military test pilots, men accustomed to danger and discipline. They became national heroes overnight. The Mercury program aimed to put a single astronaut into space and bring him back safely. In 1961, Alan Shepard became the first American in space, though his flight was brief. Soon after, John Glenn orbited Earth, proving that Americans could survive and function in space. These missions were small steps, but they built momentum and public excitement. That same year, President John F. Kennedy made a bold and risky promise. Speaking before Congress in May 1961, he declared that the United States would land a man on the moon and return him safely to Earth before the decade was out. At the time, this goal seemed almos. As Apollo 11 moved steadily toward the moon, time took on a strange rhythm for the crew. Days were measured not by sunrise and sunset, but by checklists, radio calls, and the gentle hum of onboard systems. Mission control in Houston followed every movement, every reading, and every breath the astronauts took. Hundreds of engineers worked in shifts, watching screens filled with numbers, knowing that a single mistake could mean disaster. After 3 days of travel, the moon began to fill the spacecraft's windows. What once appeared as a distant, glowing disk now revealed craters, shadows, and a surface shaped by billions of years of impacts. On July 19, 1969, Apollo 11 fired its engine to slow down and enter lunar orbit. This maneuver had to be precise. Too fast, and the spacecraft would fly past the moon forever. Too slow, and it could crash. When the engine shut down, cheers erupted quietly in mission control. Apollo 11 was now circling the moon. The astronauts spent the next orbit studying the landing site, an area known as the Sea of Tranquility. From above, it looked relatively smooth compared to other regions, but no one could be completely sure what awaited them below. Neil Armstrong and Buzz Aldrin reviewed procedures again and again. Every switch, every command had been practiced countless times on Earth, yet the reality of performing them nearly 240,000 miles away added enormous pressure. On July 20, Armstrong and Aldrin moved into the lunar module, which they had named Eagle. Michael Collins remained in the command module, Columbia, alone in lunar orbit. His role was critical. If anything went wrong, he would be the one to bring them home. As Eagle separated from Columbia, Collins watched it drift away, fully aware that he might be the only human near the moon if the landing failed. The descent toward the lunar surface began quietly, but tension grew with every passing second. The computer guided Eagle downward, but soon unexpected alarms sounded inside Inside the lunar module, silence returned as Neil Armstrong and Buzz Aldrin removed their helmets and gloves. Exhaustion set in, but there was little time to rest. The moon landing had captured the world's attention, yet the most dangerous part of the mission still remained. They now had to leave the lunar surface and reunite with Michael Collins, who continued to orbit the moon alone aboard the command module. Before liftoff, Armstrong and Aldrin prepared the ascent stage of Eagle. This small engine was their only way off the moon. Unlike on Earth, there was no backup system and no chance for repair. If it failed, they would be stranded forever. Every checklist item was completed with intense focus. On July 21, 1969, after roughly 21 hours on the lunar surface, the moment arrived. The ascent engine ignited, and Eagle rose smoothly from the moon, leaving behind its descent stage and the footprints of its crew. From orbit, Michael Collins watched the tiny craft lift off, relieved to see it climbing toward him. The maneuver went exactly as planned. In the blackness of space above the moon, the two spacecraft slowly approached one another. Docking required extreme precision. Armstrong guided Eagle toward Columbia, aligning the docking mechanisms carefully. When the two vehicles connected, Collins welcomed them back with relief and quiet humor. For the first time since the descent, all three astronauts were together again. After transferring lunar samples, equipment, and data, Eagle was sealed off and later released to drift away, its mission complete. Apollo 11 remained in lunar orbit for several more hours. During this time, the crew rested and reviewed systems for the journey home. The mission had already succeeded beyond expectations, but there was still no room for error. To leave the moon, the service module engine would need to fire at the exact moment to place the spacecraft on a path back to Earth. When the time came, Mission Control sent the command. T. As the celebrations continued across the United States and beyond, the meaning of the moon landing began to settle in. What had started as a political challenge during the Cold War had become something much larger. For many people around the world, Apollo 11 was not just an American victory, but a moment that proved what humans could achieve when knowledge, discipline, and imagination came together. Neil Armstrong, Buzz Aldrin, and Michael Collins suddenly found themselves in an unfamiliar role. They were explorers, but also symbols. Interviews, public appearances, and official ceremonies filled their schedules. Armstrong, naturally reserved, often reminded audiences that the success of Apollo 11 belonged to the hundreds of thousands of engineers, technicians, scientists, and workers who made the mission possible. Behind the three men who flew to the moon stood an entire generation of problem solvers. Scientifically, the mission delivered results that went far beyond expectations. The rock and soil samples brought back from the moon were studied by researchers around the world. These samples revealed that the moon was ancient, shaped by intense volcanic activity and countless meteor impacts. They supported the theory that the moon formed from debris after a massive collision between early Earth and another celestial body. The data collected helped scientists better understand not only the moon, but also the early history of the solar system. The experiments left on the lunar surface continued to transmit information back to Earth for years. Instruments measured seismic activity, showing that the moon experienced moonquakes, though weaker than earthquakes. Laser reflectors allowed scientists to measure the distance between Earth and the moon with incredible accuracy, confirming that the moon slowly moves away from Earth over time. These quiet experiments turned the moon into a natural laboratory. The success of Apollo 11 paved the way for further lunar missions. B2.